So this one, I was very amazed when I did this. These free Google Colab machines, I figured Google is not going to give you a whole lot of computing power for free, but in fact they give you a lot more than I expected, and you can do amazing things. So you can download a database from on my website of blurry and sharp images, and these were done by somebody who wanted to study the properties of cameras. So they just took pictures with real analog cameras of something in focus and something blurred. So you have a whole series of images, full color images with full resolution that are blurred and sharp. And so this is what happens for stable diffusion. You probably use these online image generators where you can type in, I want to see a fish riding a bicycle in the style of Picasso, and it will create it. And this is how it works. They do it by making a deblurring algorithm. And they train the deblurring algorithm to take a real Picassos and blur them, and they train their AI model to deblur into a Picasso, and then they just start with random noise and deblur it, and it will turn into a random Picasso. How they enforced the understanding of the English, I don't quite understand that part, but I do know they do it with 1,000 steps of blurring and training a deblurring image. So this sounds like a lot of computation, but it turns out to be okay. You can have your clean frames and blurry frames here. You take your training data, which is a set of these images, and you train on a set of these images. And you'll see you encode them and then decode them, is how the AI model works. And you will end up with, here's your set of parameters. Notice this is pretty awesome because the images are, I think, 256 by 256 times 3 colors. So it turns out this is more like 1 million parameters right here, and more parameters there. Total number of parameters is 17 million. Kind of thing, I wouldn't think you could do on a free little virtual machine that Google gives you, but you can. So there are 17 million parameters to adjust. So you train the model. Now, when I started doing this, it took an hour. Well, here it takes 5 minutes to go through 5 epochs of training, about a minute each. And 5 epochs means I start with random parameters, and then I take a small step in parameter space to make the error smaller. That's what 1 epoch is. And it's taking so long to do an epoch that I only did 5 of them because each one of them is taking 10 seconds. So this is just a minute or 2 of training. And after 5 epochs of training, you should be able to see an error number going down here. Loss, 0.06, 0.686662. This is some kind of measure of the error in deblurring the image because you're feeding it images where you have the sharp image and the blurry image. So it's trying to change the blurry image and make it closer to the sharp image so it can measure the error between the two, and you can see the error is going down. However, you can also see the error is still going down. In fact, it's going down faster. 68, 66, 62, 62, then 53. It doesn't seem like I've trained it enough because it's still going down a lot. What you want to do is train until you hit the bottom. Then you've got the best one you can have. And indeed, the results of this are, it is terrible. This is the sharp image, this is the blurry image, and this is what the model puts out. So it is horrible. It's useless. It's worse than useless right now after only 5 epochs of training. It needs more training. So the next thing to do was do 100 epochs of training, which takes like an hour and a half. And that's like the maximum time you can have before Google hangs up on you. So that's what I did before. And then one of my students pointed out to me something I didn't know. Google will not only give you a free virtual machine with CPU, they will give you a GPU for free. Although, if you do it too many times, they'll start limiting you or something. But you can go into the runtime type and you can tell it, I want a GPU. And that's why these things are such a premium. And every AI shop is buying them like crazy. GPUs make AI calculations much, much faster. So if you switch your runtime type to use the GPU, now you can train to 100 epochs, and instead of it taking 70 minutes, it only takes a few minutes. Much faster. So now you can train it with 100 epochs, and at 100 epochs, it actually works pretty well. This is the blurry image. See how all the pattern on that pillow is pretty much unreadable? In a sharp image, you can see it. And here's the deblurred image, which is moved sort of halfway to the deblurring one. So you can actually do significant image processing, and this is the one I see in all the cop shows on TV. They have a camera from a surveillance camera that shows a car, and you can't really read the license plate, and they say, can you clean that up? And they deblur it, and you can see it. And this is how it works. And the thing to understand is, unfortunately, when it's used for a purpose like that, law enforcement, you should know it's just guessing. It's probably not accurately reconstructing that license plate. I wouldn't assume it's accurate. It's lowered the error in the training image, but I would not assume that it's actually getting the right license plate number. Anyway, but amazing you can do this at all. And so I may have a couple of flags you can find here to get some points doing this. And you know, this is a realistic task. And I guess this is going to be on our phones now. Apple Intelligence supposedly has what Android's had for a while, the ability to fill in missing pieces of an image. And I don't know if it can de-blur images on the phone, but I would expect so. This is a modern activity. As you can see, it's not that difficult. It doesn't really require that much processing to do. So that's what I wanted to show you.